Now, for a quadratic equation, there are two aspects. One is the roots and the other is the coefficients. So, is there a relationship between these two? So, to answer that question, we take up another question. Given the roots, can we reconstruct the quadratic equation? So, given the quadratic equation, we know how to find the roots. But now we are talking of going the other way. So, let's see. Suppose the two roots are m and n. That means x is equal to m, one of the roots, which we can write it as x minus m is equal to 0. Similarly, x is equal to n implies x minus n is equal to 0. Let's multiply these two. We get x minus m times x minus n is equal to 0. Opening up the bracket, we get x times x minus n times x minus m times x plus m times n is equal to 0. So this becomes x square. These two are like terms. Minus is also common and x is also common. So minus, we take it out, x we take it out, and we have m plus n plus m times n is equal to 0. In the above equation, the coefficient of x square is 1. So let us write the general form of the quadratic equation also in this form. Remember our general form, that is ax square plus bx plus c equal to 0. Now here also, if we want the first term to be x square, what do we have to do? We have to get rid of a. How do we get rid of a? We divide both sides by a. Now let's split it into multiple fractions. Left hand side, we get ax square by a plus bx by a plus c by a is equal to 0 by a, which is 0. And now the first term becomes x square plus bx by a plus c by a is equal to 0. Now comparing the coefficient, now see here, this is a quadratic equation and this is also a quadratic equation. And they are having the same structure and they are both equal to 0. So which means we can compare the coefficients and equate them. We get b by a is equal to minus m plus n. That is, the coefficients of x are equal. Coefficients of x square are anyhow equal because they are both, in both cases, they are 1. Now what about here? C by a is equal to m times n. Let's take minus to the other side. We end up with m plus n is equal to minus b by a. And m times n is equal to c by a. So if the roots are m and n, then the equation is x square minus m plus n times x plus m times n is equal to 0. This is straightforward way of finding the equation if the roots are given. So this gives us a direct relationship between the roots and the coefficients of the quadratic equation. Now let's verify it. How do we verify it? Let's take the actual roots based on the quadratic formula itself. Let's add the roots of the quadratic. Minus b plus square root of delta divided by 2a plus minus b minus square root of delta by 2a. Denominators are same. So minus b plus square root of delta minus b minus square root of delta divided by 2a. Here square root of delta gets cancelled and we have minus 2b by 2a, which is equal to minus b by a. So the sum of the roots is equal to minus b by a. Now let's multiply the roots. Minus b plus square root of delta by 2a times minus b minus square root of delta by 2a. Now here you notice we can use, for the numerators, we can use a plus b times a minus b is equal to a square minus b square. So minus b square will be b square minus square root of delta square will be delta divided by 4a square, which is equal to b square minus, now delta is nothing but b square minus 4ac divided by 4a. B square cancels out, minus times minus plus, that is 4ac by 4a square, which gives us c by a, which is what we have. The product of the roots is c by a. So that was the relationship between roots and the coefficients of a quadratic. Now let us see how we can use this relationship between roots and coefficients of a quadratic to reconstruct the equation. So given the roots, how do we get back the equation? So let's say the roots given are m equal to 7 and n equal to 5. We know b by a is equal to minus m plus n. So minus 7 plus 5, which is equal to minus 12. C by a is equal to m times n, which is equal to 35. So now we just substitute x square plus minus 12x plus 35 is equal to 0. Simplifying it, we get x square minus 12x plus 35 equal to 0. So here, this is the equation whose roots are 7 and 5. Now let's very quickly verify it using the quadratic formula. Applying it, we get x equal to minus b, that is minus 12 plus or minus square root of b square, that is minus 12 square, minus 4ac. So 4 times 1 times 35 divided by 2 times a, that is 2. Simplifying it, we get 12 plus or minus square root of 144 minus 140 divided by 2. Simplifying it, we get 12 plus or minus 2 by 2. Now, let's split it into two values of x. X equal to 14 by 2 and x equal to 10 by 2. So, 12 plus 2 is 14 and 12 minus 2 is 10. Simplifying it, we get x equal to 7 and x equal to 5, which is what we started off with. Okay, now let's look at the next one. M is equal to 1 by 2 and n equal to 2. Again, b by a is equal to minus m plus n. So half plus 2, which is equal to 5 minus 5 by 2. And c by a is equal to 1 by 2 times 2, which is equal to 1. So our equation becomes x square plus minus 5 by 2 x plus 1 is equal to 0. And simplifying it, because ideally we should come out with an equation which doesn't have fractions. So let's multiply the whole thing by 2. We get 2x square minus 5x plus 2 is equal to 0. M is equal to root 3 and n equal to root 2. B by a is equal to minus root 3 plus root 2. And c by a is equal to root 3 times root 2, which is equal to root 6. Now, b by a, this part cannot be further simplified. So we have x square minus root 3 plus root 2x plus root 6 is equal to 0. This is the equation. Okay, so that was one of the ways in which we can use this relationship between roots and coefficients. Now let's look at another one. Find the missing coefficient. So here, let's say the equation that is given to us is x square plus bx plus 81 is equal to 0. M is equal to 9, n equal to 9 because multiplicity is 2. M plus n is equal to minus b by a. So which means 9 plus 9 is equal to minus b by 1 because a is 1, which gives us 18 is equal to minus b, or b is equal to minus 18. So we have found b. So our equation becomes x square plus minus 18x plus 81 equal to 0. That is x square minus 18x plus 81 equal to 0. And this can be written as x minus 9 the whole square is equal to 0. Now let's look at the second one. Here ax square plus 3x plus 1 equal to 0 is given and the roots are minus 1 and minus half. We have to find the coefficient of x square, that is a. Again, m equal to minus 1, n equal to minus half. M times n is equal to c by a. M times n is minus 1 times minus half, which is equal to c by a, that is 1 by a. This gives us 1 by 2 is equal to 1 by a, and taking reciprocals on both sides, we get a equal to 2. So our equation is 2x square plus 3x plus 1 equal to 0. Let's very quickly find the roots of this equation. X equal to minus 3 plus or minus square root of 3 square minus 4 times 2 times 1 divided by 2 times 2, which gives us minus 3 plus or minus root 9 minus 8 by 4 minus 3 plus or minus root 1 by 4, which is minus 3 plus or minus 1 by 4. So x equal to minus 3 plus 1 by 4 and x equal to minus 3 minus 1 by 4. X equal to minus 2 by 4 and x equal to minus 4 by 4, which means we have x equal to minus 1 by 2 and x equal to minus 1, which is what we were given. These are the two relationships. M plus n is equal to minus b by a. M times n is equal to c by a. So given the roots and any two coefficients, we use m plus n equal to minus b by a to find the missing coefficient a or b. And we use m times n equal to c by a to find the missing coefficient a or c. For a given set of roots, there are infinitely many quadratic equations having these roots. However, only one of them has its coefficients in the simplest integral form. For example, x square minus 5x plus 6 equal to 0. Right? This has the roots 2 and 3. Now let's take a multiple of this. So we multiply the first equation by 2. We get 2x square minus 10x plus 12 equal to 0. Its roots are also 2 and 3. Let's multiply the first one by 7. So 7x square minus 35x plus 42 equal to 0. Its root is also 2 and 3. So here the first equation is the unique one with coefficients in the simplest integer form. So let's very quickly look at the graph. So if we draw the graph 2 and 3, let's move this aside for the moment. This is the equation for x square minus 5x plus 6. This is for 2x square minus 10x plus 12 equal to 0. And this is for 7x square minus 35x plus 42 equal to 0. And each of these graphs are intersecting the x-axis at 2 and 3, which are the roots. That was roots versus coefficients of a quadratic. That's it for now.